All right, so 9.6 is about ratio and root test. My goal today is kind of talk about each of the the tests via the theorems, and then if we have some time, we'll talk about problems. But I want to go through and talk about each of the theorems. And like I said, I already posted it to Classroom, so if you want to check out the section there, you can and follow along with that. It is up to you. But theorem 9.17 is the ratio test. And this says let the summation of a sub n be a series with non-zero terms. One second. All right, sorry about that. Luke walked in and asked some questions. So we have the series summation a sub n converges absolutely when the limit as n approaches infinity of a sub n plus 1 over a sub n equals, and that's supposed to be an infinity. I just didn't leave myself a lot of room. And then the second one, the series summation a sub n diverges when the limit as n approaches infinity of a sub n plus 1 over a sub n is greater than 1, or, wait, I wrote this wrong. Sorry. This is supposed to be less than 1. Sorry about that. I'd gone goofed on that. I thought it looked weird. N approaches infinity, and then a sub n plus 1 over a sub n, absolute value closed, equals infinity. So whether it's either greater than 1 or equal to infinity, then it diverges. And the third one is where the ratio test comes into play. So the ratio test is inconclusive when the limit as n approaches infinity of a sub n plus 1 over a sub n when it equals 1. So if it's less than 1, converges. If it's greater than 1 or infinity, it diverges. If it equals to 1, it's inconclusive, so you don't have a solution. And the idea of ratio test is you should have a ratio or fraction. We have that in each case. So that gives you the rundown of that little fun theorem slash test. And like I said, we're going to go back and we're going to look at problems, but I want to make sure to have both tests written down first before going into problems.
20%.
Okay, it'll be fun.
What is it?
It is fun.
What is it?
Sorry. Luke was using my phone. He's like, it's 20%. He's like, I was like, it'll be fine. He's like, it won't be okay.
I'm not ready.
Oh, my bad.
Okay.
That's funny. There you go.
Thank you.
So the ratio test is going to have to do everything. It's all going to be fraction based, so that kind of helps. Where the root test is all going to be based off of radicals and roots. So there should be like a clear, concise, noticeable difference between them. And just let me know when you guys are ready for me to turn the page, and I'll start the root test.
I'm ready, but I don't know if other people are ready or not.
Is everybody else good?
Yep.
Okie dokie. All right, so that leads us into theorem 9.18. Which is root test. And we're going to notice some similarities here. In fact, they're almost exactly the same. The series with the summation a sub n converges. Absolutely. When the limit as n approaches infinity of the nth root of a sub n is less than 1. So that's the same rule as before. Well, then you can guess that the second rule, the series, the summation a sub n diverges when the limit as n approaches infinity of the nth root of the absolute value of a sub n is greater than 1, or the limit as n approaches infinity of the absolute or the nth root of the absolute value of a sub n is equal to infinity. Which means then you guessed it, for step 3, the root test is inconclusive.
Are we doing examples for both these today?
Yeah. I don't know if we'll get through all the examples, but we are going to start them at least. When the limit as n approaches infinity of the nth root of the absolute value of a sub n is equal to 1. So really the rules are exactly the same. You're just replacing the ratio with the root now.
Can you scoot it up a little bit?
Like that?
Yeah.
Okay. Also, if you look at the textbook on the page 636 that I posted, it goes through the summary of all the tests for series, and gives a little chart of them if you ever want to look at that. It's there. I'll give you all a minute to write this down, and then we'll talk about a problem. And just let me know when y'all finish, and I'll flip the page over.
I'm ready. I don't know about anybody else.
Is everybody else good? Yay or nay?
All good.
Okay.
I'm good.
Okay. So this leads us into an example. And we're going to, it's the same wording as what you've had for the past few sections where it's like determine the convergence or divergence. And then it'll say, for instance, we're going to look at the summation as n approaches 0 to infinity of 2 to the nth power over n factorial. All right, this is ratio test because we already have a fraction, so we're good there. There's some other like ways to tell, but for right now, we're just going to focus on ratio tests because you can have root tests with fractions as well, but we'll talk about that in a bit. So the idea is you want to identify what a sub n is, and a sub n in this case is your original value here, so it's 2 to the nth over n factorial. Then we have to think about, we want the limit as n approaches infinity of a sub n plus 1, which, if I know what a sub n is, a sub n plus 1 is equal to 2 to the n plus 1 over n plus 1 factorial.
That's really hard to read. Can you like zoom it maybe?
I don't have a zoom feature, so no.
Oh.
So I'll just do this. A sub n plus 1 is equal to 2 to the n plus 1 over n plus 1 to the factorial. I'll let y'all get that written down, and then if you want to attempt it or think about it, you have a minute before I do it. Give me 1 second.
This is really hard.
Okay. So now we have a sub n and a sub n plus 1. We can do our limit and say the limit as n approaches infinity of a sub n plus 1, which is our 2 to the n plus 1 over n plus 1 factorial, is divided by 2 to the n over n factorial. And we know with fractions that if we have division, we can change that. And it would be 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n, because we have keep, change, flip. Are we okay with that part? That's just following the rule.
Yes.
Okay. So once we have that, we can think about what's going to happen. If you don't remember, when you have something like this that says 2n plus 1, 2 to the n plus 1, you have to remember when you exponents add when you have like bases that multiply. So really that's like 2 to the nth times 2 to the 1. So our 2 to the nths cancel out. So algebra comes back to haunt a bit here. So this leaves you with a 2. And if you had factorial, you'd have n to the n plus 1 factorial. And then you'd have plus n, or times n. So we write out the factorials. The n's factorials go away, and it just leaves you with n plus 1.
Can you scoot it down a little bit?
Yeah. All right, if you plug in infinity in the denominator, what does this make this go to?
Zero.
0. So 0 is less than 1, which means what? It converges. Done.
Okay, I understand everything except when you added the 1.
This part?
Yeah.
Like the purple? Because you have a sub n, right? And then everywhere there's an n, you're adding a plus 1 when you do a sub n plus 1. Like each of these n's gains a plus 1. So you'll always identify what a sub n is. And then when you do a sub n plus 1, you're just adding a plus. You literally just do plus 1 to each n in the problem. It's basically saying that if I have... I'll wait for everybody to finish this page real quick, and then I'll describe it in a different way.
And this is for 9.17.
9.17, yeah, the ratio test.
So, how did you get 0? I'm sorry.
Because if I plug in infinity in the denominator, it's going to go towards 0.
Oh, okay.
Okay, so let's talk about... Maybe I could write it here. If I have an a sub n that says a sub n equals 2n plus 1, right?
I missed something on the computer.
All right, 1 second. All right, I'm back. Sorry, Luke messed up a tab on the computer. Okay, if this is a sub n plus 1, right? You can kind of think about it like this. If I did a sub n and then did a plus 1, I'd get 2n plus 2. But it's kind of like thinking like this. If I have a sub 0, I plug in 0, and I get 1. But if I add 1, right, to 0, that gives me a sub 1, which then gives me 2 to the 1 plus 1 equals, which gives me 3. Does that make sense? Like, the only difference is when I do a sub n plus 1, I've now changed what my series starts with, so now it's 2n plus 2.
Okay.
So it gives me like a slightly different series because I'm adjusting my n value.
And you just do that every time.
Yeah, every time you're doing ratio test, every time. I don't know if that helps at all. Maybe it does. Maybe it's just needing to see it more. I don't know. We can look at another one though. Okay, we'll try this one and see what happens. All right, so the directions are the same, so I'm not going to rewrite the directions. It's just determine converges, diverges. And they give us the summation of n equals 0 to infinity. And you get n squared to the 2n plus 1 over 3 to the n. All right, again, you know a sub n because a sub n is what they originally give you. That's the n squared to the n plus 1 over 3 to the n. So you need to find out what is... That's blue again. I thought I grabbed purple. That's fine. I'll just... You need to find out what a sub n plus 1 is. And we know that we have, well, that's n plus 1 squared. And then I have 2 to the n plus 2 over 3 to the n plus 1. Does that make more sense? Like, we're literally just adding 1 to wherever there's an n.
Yeah.
Okay. So the same rule applies. You're still going to go through and say, okay, well, I need to... Let me use brown this time because that pink's kind of hard to see. The limit as n approaches infinity, and then you write your a sub n plus 1 value. So you have n plus 1 squared, 2 to the n plus 2 over 3 to the n plus 1. I'm just going to go ahead and skip the step of division and say we're going to keep it, change it, and then flip the other one. So you have 3 to the n over n squared, 2 to the n plus 1, and then do that. Basically what you're going to do each of these times is you're going to end up canceling a bunch of stuff out. So you have to think about it in the algebraic way of how are things canceling. All right, and this leaves us with limit as n approaches infinity. And we're going to go from that to 2 to the n plus 1 squared. And then we have a 3 down here. Okay, so 3n squared. Okay, so let me walk through what just happened. n plus 1 squared doesn't have anything to cancel out with, so it's fine. You have 2 to the n plus 1. You have 2 to the n plus 2. You just left with 1 because you basically have the 2's to the n's divide out, and you have 2 squared divided by 2, so it leaves you with a 2. Here you have 3 to the n and 3 to the n plus 1. So your 3 to the n's cancel out, and you're left with 3 to the 1. You have nothing to cancel out with n squared, so n squared. It's just a bunch of algebra that needs to happen all at one time. You could try to separate out in steps if that helps. I could see that becoming more complicated. Wait, did I miss a step? No, wrong problem. Oof, that was almost bad. Okay, n squared's the highest power, right? Like if I FOIL this out, I'm going to get an n squared here.
Yeah.
Yeah.
Okay, so I just take my leading coefficients. My leading coefficient is 2/3. Is 2/3 less than or greater than 1?
Less than.
Less than 1, so it converges. So I don't think it's terrible. It's just a lot of like little algebra steps you have to pay attention to and watch.
And this is also for 9.17.
Yeah, I'm strictly doing ratio test right now.
Okay.
I'm not gonna actually. I'll save root test for tomorrow, just so that way you can have a separation of the two for problems.
Like, I get the process, but I don't think I can do the algebra.
Really, just here's what you want to do, right? Look at your first term, n plus 1 squared. Is there another one? No. So you know this is going to carry down, right? Like that's going to happen. You get to 2n plus 2, and you see 2n plus 1, right? So you know the two n's are going to cancel out. So when that happens, you end up with a 2 squared and a 2 to the 1. Well, 4 divided by 2 is 2. So you've dealt with that step because this goes away. This and this. Then when you get to here and you're like, hey, I have a 3n and a 3 to n plus 1. Well, there's talked about writing it like that. So that way this goes away and this goes away. So you have a 3 and then there's n squared just left over. You just need to take it step by step. And I'm not saying it's going to be easy. I think it's going to take a process of getting used to it. But I think it's just look at it piece by piece. Don't look at it as like the whole entire problem and be like, okay, so this is here and like, and this is the, like, I'm trying to cancel out and like trying to pick, literally just go by each multiple. I think that's probably a better way to look at it. I'm going to also end the recording there.